This planet is hotter than most stars. Kelt 9b circles so close to its brilliant host star that one side of the planet reaches nearly 4,600 Kelvin. At that temperature, familiar ideas about planets begin to fail. A gas giant should have an atmosphere wrapped around it like a stable shell. Kelt 9b appears to have one. It glows blue-white against the light of a star already blazing at more than 10,000 Kelvin. Yet every measurement points toward the same unsettling conclusion. The very material that defines its atmosphere should be struggling to remain an atmosphere at all. From a distance, the scene almost looks familiar. A giant planet orbits a star every day and a half, locked so that one hemisphere never escapes the relentless daylight. But familiarity ends there. The star itself is no ordinary sun. It spins so rapidly that it bulges around its equator, its poles becoming hotter and brighter than its middle. Kelt 9b passes through this extraordinary environment again and again, enduring conditions that resemble the surface of many stars more than the surroundings of any planet we know. The glowing envelope around the planet is impossible to ignore. It is the first clue that something about this world refuses to fit our expectations. The obvious assumption is simple. Perhaps this is merely the hottest version of Jupiter imaginable, a place where the atmosphere is superheated, but still fundamentally the same, just hotter. The evidence does not support that idea. When astronomers separated the star's light during the planet's transit, they were not searching for dramatic images. They were looking for tiny fingerprints hidden inside the light itself. Every chemical element absorbs specific wavelengths. Together, those missing wavelengths become an invisible signature. What appeared in those signatures changed the investigation. Instead of finding the molecular chemistry expected in a giant planet, researchers found something far stranger: molecular hydrogen. The basic building block of giant planet atmospheres could not survive the dayside heat. The thermal energy was so intense that the molecules split apart into individual hydrogen atoms. The atmosphere had crossed a boundary. It was no longer simply hotter. Its chemistry had changed identity. Other familiar molecules, including water vapor and methane, were absent from the blazing dayside. In their place appeared unmistakable evidence of vaporized metals. Iron existed as gas. Ionized titanium drifted through the atmosphere. Calcium and other atomic species revealed themselves one spectral line at a time. The glowing envelope surrounding Kelt 9b returned with a different meaning. At first, it seemed to represent an extraordinarily hot atmosphere. Now it represented a place where ordinary molecular chemistry had largely ceased to exist. The planet's skies behaved less like weather and more like an extension of stellar physics. Even then, one question remained. If the atmosphere had been chemically torn apart, why was it still there? The next observations shifted the mystery again. Scientists examined a specific wavelength of hydrogen known as the H-alpha line. Instead of seeing a compact atmosphere held tightly by gravity, they found evidence of hydrogen stretching far beyond the planet's expected boundary. The atmosphere was no longer confined to the planet alone. It extended outward into space. Measurements revealed an enormous cloud of hydrogen surrounding Kelt 9b. Models supported by these observations indicated that heated gas was escaping through a process known as hydrodynamic escape. The atmosphere expanded until gravity could no longer fully contain it. The planet was slowly losing part of itself. Not through explosions, not through fire, simply because relentless radiation kept pushing its outer layers beyond their limits. The glowing envelope returned once more. This time, it was no longer just an atmosphere. It had become evidence of continuous loss. The same feature that proved the planet existed was also proving that material was escaping into space. For a moment, the conclusion
At this
seems
scale,
unavoidable.
The planet is dwarfed.
A
Yet
planet losing its
fragile
atmosphere should
remains
eventually
its
disappear.
defining feature.
That expectation feels natural, because destruction usually suggests something rapid and final. Reality is more complicated. Although Kelt 9b is continuously shedding material, it remains an enormous gas giant. The estimated rate of atmospheric loss is immense by human standards, yet the planet itself contains such extraordinary mass that the process unfolds across astronomical timescales rather than human ones. Researchers can confirm that atmospheric escape is happening. They cannot confidently predict exactly when the planet will cease to exist, because those estimates depend on uncertain factors such as magnetic fields and interactions with the stellar wind. The important discovery is not that the planet is dying tomorrow. It is that survival and destruction are happening together. The atmosphere continues to define the planet, even as part of that atmosphere escapes into space. The opening image now carries an entirely different meaning. That luminous shell surrounding KELT 9b is not a permanent boundary separating planet from space. It is a changing frontier. Molecules are broken apart. Atoms dominate where stable chemistry once would have existed. Hydrogen stretches beyond gravity's comfortable reach. Material slowly leaks away while the massive world beneath endures. Kelt 9b remains a planet. Not because nothing is changing, but because the process of being undone is slow enough that the planet persists, even as the evidence shows its atmosphere is continuously being remade and continuously being lost.